Hello everyone, welcome to Howard's Little World of Math. Here we will teach you all the techniques of calculus. It includes integration by parts, U substitution, trigonometry metric substitution, and even double integrals. Whatever method you can think of, we have all covered it. And we like to share all the wonders of mathematics with you. So let's jump into today's lesson.
Okay, so now we are going to solve this problem. Let integral tangent to the fourth times second cube. At first, if we try u substitution, then we let u equals to secant x. And we can apply the formula that tangent square is equals to secant square minus 1. We can organize the calculation. But we can see that there will remain a tangent x that we cannot eliminate it. So let me try another one. This time, we let u equals to tangent x. But we can see that there will also remain a secant x that we can't calculate. So it seems that u substitution cannot solve this problem at all. So maybe we should find another method. Now, if we observe the question, we can see that we can turn all tangent x into secant x by applying tangent x squared equals to secant x squared minus 1. And the original question can be divided into 3 parts. But how do we deal with it? Let me try the simplest problem that integrates second cube. And we can observe that if we use u substitution and we let u equals to the terms of secant x, when we differentiate the secant x, we always leave a tangent x that is difficult to deal with. So maybe we should try another method that is integration by part. So let's do it.
First, we let u equals secant s and dv equals secant s squared dx. And du equals tangent x times secant s dx, and v equals tangent x.
And as you can see, we prefer to put secant square into dv, since it is easy to integrate. And we put the other parts into u, and it is also easy to differentiate. So this concept will be applied in the whole video when we do integration by part. So you can pay attention to the parts that when we assign u and dv when doing integration by part.
So after calculation, and calculation. Next, we put the integral of secant s cubed to the same side. Now we can get the integral of secant s cubed equals tangent x times secant s plus ln secant s plus tangent x divided by 2, and this is our result. Be careful that this place we need to use the knowledge taught by teacher on the class. So it's important to listen to Howard's class, or you can solve this problem successfully. And after that, the integral of secant s cubed, we can change it to the integral of secant x. So we guess that if we can change the integral of secant s to the n plus 2 to the integral of secant s to the n, it's success. We can solve the other complex integral successfully. So next, move on to the secant s to the 5. We let u equals secant s to the 3 and dv equals secant s squared dx. So after calculation, we can get this result. And then we put the integral of secant s to the 5 to the same side. So we can get that it is tangent x times secant s to the 3 plus 3 times the integral of secant s cubed divided by 4. And we done this problem. Next, move on to the integral of second s to the 7. We do the same thing as well. It's integration by part and our correct calculation. Now we can get the result on the red line above. You can find that we almost done this problem. Now we solve the integral of second s to the 3, to the 5, and to the 7. We have this result, so we can move on to another calculation, and it is quite an easy part. Calculation, 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 and calculation, and finally we get the result. And this place we finally get our result.
Wait a minute. Although we solve this problem correctly, there's also a point that is worth observing. By the previous calculation, we can see that there are some rules between the formulas above, like the coefficient and the power of second are proportional. So by the observation, we can organize them into a below formula. And we guess that the formula can be applied when n is an odd number. That's right, but the equations above are situations when n is an odd number. And you have to know that what if n is even? So we can try to put some even number into n, like integrate second square. And we can see that this case fits the formula. And if we try to integrate second to a fourth, we can see that it also fits the formula. So we guess that this formula is valid when integrate all terms of second. So now, let we integrate a general problem by applying the same idea that integration by part. And as you see on the screen, we can also find the same terms in both sides. So now, we can put them together and get a formula for a natural number n including 0. So next time, if we see this term of problems, we can apply the formula and we can solve them easily. And we can also solve many trigonometric integral problems, like when n is an even and m is an odd number, just like today's example. We can use integration by part by changing all tangent into second. And if both n and m are even numbers, we can use substitution that change some second into tangent by the formula that tangent square equals to second square minus 1, and leave a second square for a differentiate of tangent. And if n is an odd number, while m is an even number, we can do the same thing as the previous situation. And if both n and m are odd numbers, we can also simply use substitution that change some tangent into second, and just leave tangent x for a differentiate of second. Use substitution that change some tangent into second, and just leave tangent x for a differentiate of second.
Okay, today's lesson is finished. Thanks for your watching. Remember, subscribe, likes, and hit the bells. See you next time. Bye bye.